1986. The Baltic Sea. The coast near Baltisk. In the early morning, mist crawls over the water, and observers on the shore hear a rising roar that makes the ground vibrate beneath their feet. Out of the gray veil, something so enormous bursts forth at incredible speed that the first thought is that a ship has lost its mind and decided to throw itself onto the land. But the machine does not stop at the water's edge. It continues to rush forward, kicking up a wall of sand and water spray behind it, and comes to a halt already on the shore. The bow ramp drops down with a crash, and from the belly of this giant, 3 main battle tanks roll out one by one, ready for combat. This is not science fiction or footage from a movie about the wars of the future. These are the first sea trials of the Project 1232 air cushion landing craft, named Zuber, the largest hovercraft in human history, which to this day no one in the world has been able to replicate or surpass. But to understand why Soviet engineers even thought of building such a monster, one must go back several decades and look at the map. The Soviet Union had a colossal problem that the West preferred not to think about. Thousands of kilometers of coastline from the Baltic to the Pacific Ocean, from the Black Sea to the Arctic, and at the same time, a catastrophic shortage of deep-water ports. The Baltic Sea freezes in winter. The Caspian is shallow, and in the Pacific Ocean, conditions are so harsh that not every ship is capable of working there year-round. Classic landing ships used by the Americans required equipped piers and sufficient depth near the shore. The Soviet Union did not have such a luxury. Back during the Second World War, the Americans transferred several hundred Ford amphibious vehicles to the Soviet Union under the Lend-Lease program, and the Soviet military appreciated the very idea of equipment capable of working on both water and land. After the war, based on these machines, the Soviet Union began producing its own amphibians, specifically the Gaz-46 amphibious car, which went into production in 1952. At least 600 such machines were produced, and they were actively used by the Soviet Army and the armies of allies. But amphibious jeeps are one thing, and the task of transporting an entire tank company with equipment and infantry across the sea is quite another. In the 50s and 60s, Soviet designers began to seriously look at hovercraft technology. The principle was elegant in its simplicity. Powerful fans pump air under the hull of the vessel, creating a cushion that lifts the machine above the surface. Friction with the water practically disappears, and the ship can accelerate to speeds unthinkable for ordinary vessels. But the main advantage is not even in speed. A hovercraft is capable of coming out of the water onto the shore and continuing to move over land, over sand, over snow, even over ice. It does not need a pier, it does not need depth, it does not need a port. It simply flies onto the shore and lands troops directly on an unequipped coast. The first serious step was Project Jairon, which received the NATO designation IST class. These air cushion landing craft began to be developed in the mid-60s, and for those times, they were a real breakthrough. The full displacement when loaded exceeded 300 tons, and the hold could accommodate 4 light tanks or 2 medium ones, or 3 armored personnel carriers and 100 paratroopers. Jairon craft were built in series and entered service with the Navy, proving in practice that the concept works and that large air cushion landing craft are not a toy, but a real combat asset. The last Jairon left the slipways in 1986. And this did not happen by accident. It was at this moment that it was replaced by the Zuber, which turned out to be almost twice as large as its predecessor. The Soviet military by that time already clearly understood what they wanted. They needed a ship that could independently deliver a full-fledged strike group to an unequipped shore. Not a couple of light tanks, but heavy armored vehicles, infantry, and ammunition in quantities sufficient to capture a bridgehead. At the same time, the ship had to be fast, so that the enemy would not have time to organize a defense, and sufficiently armed to independently suppress firing points on the shore at the moment of landing. The Americans by that time were also developing their air cushion landing craft, that same LCAC, but their approach was fundamentally different. The American ship was created as a pure transport, deliver the cargo and return. Soviet engineers set the task of creating not just a vehicle, but a full-fledged combat unit capable of independently conducting battle during landing, and they coped with this task in such a way that the whole world still cannot recover from the result. The assignment for designing the new generation ship came to the Almaz Central Marine Design Bureau in 1978. Project number 1232, and code-named Zuber, was led by chief designers Ozimov, Mokov, and Semyonov. The team faced a task that at that time seemed on the verge of impossible: to create a hovercraft capable of carrying 150 tons of payload, which was almost double the capabilities of the predecessor Jairan class. At the same time, the machine had to become faster, receive enhanced artillery and electronic armament, and maintain the ability to come out onto an unequipped shore. Construction of the first hulls began in 1983 at two enterprises at once: the Primorsky Shipbuilding Plant and the Moore Shipbuilding Plant in Feodosia. The lead ship of the series, number MDK-95, was effectively an experimental prototype. It was launched in 1986, underwent lengthy trials, and only in 1988 was it officially accepted into the combat strength of the Navy. When the Zuber finally took its shape in metal, it became clear that the world had never seen anything like it. The full displacement of the ship at maximum load reached 555 tons. The hull length was 57.3 meters, the width was 25.6 meters, and the greatest height on the air cushion reached 21.9 meters. For comparison, the American LCAC landing craft, which entered service in that same year 1986, weighed just over 200 tons at full load and was significantly more compact. The difference was explained not just by the dimensions of the hull, but by the fact that the Soviet designers embedded a completely different philosophy of use into their ship. The heart of the Zuber was a power plant of 5 gas turbine units, each with a capacity of 10,000 horsepower. The total power is 50,000 horsepower, which is comparable to the thrust of a small airliner. 2 units worked exclusively for the lift system. They rotated 4 NO-10 injection devices with axial impellers with a diameter of 2.5 meters each, which forced air under the flexible skirt of the hull, creating an air cushion. The remaining 3 units drove 3 huge propellers with a diameter of 5.5 meters, installed in annular nozzles made of polymer composite materials on the stern. It was these propellers that pushed the 500-ton monster forward with a maximum speed of up to 60 knots, which is more than 110 kilometers per hour. To realize this figure, most pleasure boats travel at a speed of 20 to 30 knots, and large warships rarely accelerate faster than 35. The Zuber on its air cushion outran practically everything that floated in the ocean. The range was up to 300 nautical miles, that is, about 560 kilometers, and the endurance was 5 days. The hull was made entirely of high-strength, corrosion-resistant aluminum-magnesium alloy, which provided a combination of lightness and strength. The ship was controlled centrally from the main command post, the central control post, or from remote panels using automation elements. 2 power plants based on gas turbine generators with a capacity of 100 kilowatts each worked on board. The ship's ability to overcome obstacles on land deserves a separate discussion. The Zuber could climb a slope of up to 5 degrees on an unequipped coast and overcome vertical walls up to 1.5 meters high. Thanks to these properties, up to 70% of the total length of the coastline of the world's seas and oceans was accessible to the Zuber. A colossal figure, meaning that hiding from such a landing craft was practically impossible. The ship could move through swamps, bypass ditches and trenches, and sea mines in coastal waters posed no threat to it. The machine soared above the surface without touching the water. The crew of the Zuber consisted of 27 people. and the training of each of them took significantly more time than for any other landing craft in the Soviet fleet. But those who mastered this machine received a tool in their hands for which no equal existed in the world. The Zubr carried such an arsenal that it could well be taken for a small missile ship rather than a landing craft. The main firing assets were two A-22 Ogon launchers, the naval version of the famous Grad multiple launch rocket system. Each launcher was equipped with 66 unguided rockets of 140.3 mm caliber. In total, this is 132 munitions capable of turning a section of the coast into a solid wall of fire in seconds. These launchers were intended for suppressing enemy firing points directly at the moment of landing, and their volley density was comparable to the strike of an entire coastal battery. Trenches, fortifications, light armored vehicles, all of this was burned out completely before the first tank rolled down the bow ramp onto the sand. The work of the Ogon launchers was managed by a special fire control system that ensured accurate aiming even in conditions of rolling and movement of the hovercraft. The anti-aircraft defense of the ship was provided by two 30mm six-barreled automatic artillery mounts, AK-630M. Each of them fired up to 5,000 shells per minute, creating an impenetrable wall of metal in the path of aerial targets. The AK-630 was originally created as a naval means of close-in defense against anti-ship missiles and low-flying aircraft. And on the Zubr, it worked equally effectively against both aerial and light naval targets. The anti-aircraft ammunition load was 3,000 shells. Aiming and tracking of targets were carried out by the MR-123-0 radar fire control system, which detected and tracked targets in automatic mode. In addition to the rapid-fire guns, there were 8 sets of Igla man-portable air defense systems on board, allowing for the engagement of low-flying helicopters and aircraft at close distances. Thus, the Zubr possessed a layered anti-aircraft defense system. First, the target was met by Igla missiles, and if it broke through closer, it was covered by the heavy fire of the AK-630. In addition to all this armament, the Zubr could take up to 80 sea mines on board. This turned it into a high-speed mine layer capable of blocking an entire strait or harbor approach with mines in one mission. Moreover, it could do this at a speed inaccessible to any specialized mine-laying ship in the world. Such flexibility of use made the Zubr a universal combat unit. In one mission, it could lay a minefield, and in the next, land troops with tanks. The cargo compartment was no less impressive than the arsenal. The hold could accommodate 3 main battle tanks with a total mass of up to 150 tons with crews, or 10 armored personnel carriers with a total mass of up to 131 tons, and 140 paratroopers, or 8 infantry fighting vehicles with a mass of up to 115 tons, or 8 amphibious tanks. When used exclusively for transporting infantry, the ship accommodated up to 506 troops with full equipment, a capacity comparable to a Boeing 747 passenger plane. Only this Boeing was rushing over the waves and was armed to the teeth. The designers from Almaz also provided protection against the most terrible weapons on the planet. The ship's superstructure was divided by 2 bulkheads into 3 isolated compartments. The troop hold was located in the middle part, and the main and auxiliary premises, including living quarters, were located along the sides. The entire ship was completely airtight. In the event of the enemy's use of nuclear, chemical, or biological weapons, the crew could batten down all hatches and continue performing the combat mission in a contaminated environment. The electronic equipment included a navigation complex, a satellite navigation system, and a gyro compass. Despite all this combat power, the life of the 27-person crew inside the Zubr was far from comfortable. 5 gas turbines created a monstrous level of noise and vibration, and without special hearing protection, it was physically impossible to be on board. The seaworthiness of the ship guaranteed the use of all types of weapons with waves up to 2 meters and winds up to 12 meters per second. But even in calm weather, the hull shook continuously, and service on the Zuber was considered one of the most difficult in the entire fleet. Greece became the first and only buyer of the Zuber within the North Atlantic Alliance, and this deal itself looked almost incredible. A NATO member country acquires the world's largest landing craft from a former potential adversary. Such a thing seemed unthinkable just a few years before. But the Greeks had their reasons, and these reasons were quite pragmatic. Greece is not just a peninsula, but a huge archipelago of several hundred inhabited islands scattered across the Aegean and Ionian seas. Ensuring the security of each of them by traditional naval means is incredibly difficult and expensive, and in the event of a conflict with neighboring Turkey, with whom Athens had strained relations for decades, a means was required capable of lightning-fast transfer of heavy equipment to any island. The contract for 4 Zuber-class ships was signed in the late 90s, and the first machines entered the Greek naval forces in the early 2000s. The Greeks got exactly what they wanted: the ability to deliver tanks and infantry to any of their islands in a matter of hours, without waiting for traditional landing ships to make a slow crossing through the Aegean Sea. However, the excitement over the new possibilities quickly gave way to a headache. The Zuber turned out to be monstrously expensive to maintain. The gas turbines required regular replacement of components, and spare parts could only be obtained from Russia or Ukraine. The logistics of supplying components across half a continent turned out to be complex. Repair times were dragged out, and the cost of each technical maintenance hit the military budget hard. Greece, already experiencing economic difficulties, increasingly wondered if it was paying too high a price for its flying fortresses. According to available data, in the coming years, the Greek fleet plans to decommission the Zuber craft, having failed to find a way to make their maintenance economically justifiable. But if the Greek story of the Zuber is a tale of gradual disappointment, the Chinese chapter turned out to be much more dramatic. In 2009, Ukraine, where the Moore plant in Feodosia was located, the only enterprise that built Zubers in series, signed a contract with the People's Republic of China for the construction of 4 ships. The deal amount was about $312 million, that is, about $78 million per unit. For comparison, a finished American LCAC cost about $27 million, that is, almost 3 times cheaper, but the price did not bother the Chinese. Beijing was actively building up its landing capabilities, looking closely toward Taiwan and the disputed islands in the South China Sea. And the Zuber fit perfectly into this strategy. The first 2 ships were built at the Moore plant in Feodosia and delivered to China by sea. The Chinese side received not just finished machines, but also technical documentation that allowed for the establishment of its own production in the future. The remaining 2 ships from the contract were supposed to be built already, with more active participation from the Chinese side and the gradual transfer of technology. And here, history made a sharp turn. In 2014, Crimea became part of the Russian Federation, and the Moore plant in Feodosia found itself on Russian territory. The Ukrainian enterprise instantly became Russian, and all current international contracts fell into a zone of legal uncertainty. The Chinese order, which had been concluded with Ukraine, formally hung in the air. Despite this, available data indicate that the contract was ultimately completed, and the naval forces of the People's Liberation Army of China received all 4 ordered ships. Today, these 4 Zuber craft are part of the Chinese fleet and regularly participate in exercises for landing naval assault groups, including in the waters of the South China Sea. For Russia itself, the situation turned out paradoxically. The country that created the Zuber and the only one that possessed a full production cycle, by the middle of the tens, had only 2 ships of this type in a combat-ready state. The rest of the machines, built back in Soviet times, had already exhausted their resource by that moment. The planned service life of the Zuber was only 16 years. Gas turbines working in conditions of constant contact with salty sea air and water spray wore out significantly faster than the engines of ordinary ships, and the aggressive sea environment destroyed elements of the flexible air cushion skirt. A ship created for fast and powerful dashes across the sea paid for its exceptional characteristics, with a short lifespan and a constant need for expensive repairs. In 2017, the Russian Ministry of Defense made a statement that shook the entire naval world. Russia announced plans to resume serial production of the Project 1232 air cushion landing craft at that very Moore plant in Feodosia, which was now under Russian jurisdiction. The news sounded loud and promising. The world's largest hovercraft would return to the assembly line, and the Russian fleet would finally receive modern machines to replace the Soviet examples that had exhausted their resource. Military experts on both sides of the ocean began to discuss what this would mean for the balance of power in the Black and Baltic Seas. Russian military analysts were already building plans for updated landing groups. But months went by, then years, and not a single new hull appeared on the slipways of the Moore plant. The enterprise, which had built hovercraft for decades, faced serious difficulties after the change of jurisdiction. Production chains established back in Soviet times and maintained during the Ukrainian period turned out to be broken. Some components were previously supplied from other regions of Ukraine, some from countries that imposed sanctions against Russia after 2014. Restoring the full production cycle at a single plant, even one with unique experience, turned out to be a task far more complex than expected. Many observers came to the conclusion that the loud statement about restarting production was rather a political gesture aimed at the residents of Crimea, a demonstration that the peninsula would play an important role in the defense industry of Russia and that jobs at the Moore plant would be preserved. Meanwhile, changes were taking place in world military shipbuilding that called into question the very concept of giant air cushion landing craft. The experience of local conflicts and the development of anti-ship weapons showed that the enormous size of the Zubr, once its main trump card, turns into a serious vulnerability. A ship with a displacement of over 500 tons, flying over the water in a cloud of spray and the roar of turbines, represents a colossal target for modern anti-ship missiles, guided bombs, and strike drones. The electronic warfare means and decoys installed on the Zubr were designed in the 80s and have since become obsolete, while the accuracy and range of weapons have grown many times over. The loss of one Zubr with 3 tanks and hundreds of paratroopers on board is a catastrophe comparable to the death of an entire battalion in a matter of seconds. That is why most modern naval doctrines have bet on the dispersal of forces. Instead of one huge ship carrying everything at once, preference is given to a multitude of small and medium landing assets, individual amphibious armored vehicles, light hovercraft, inflatable landing craft for special forces. If one of them is destroyed, the losses will be limited and will not disrupt the entire operation. This same principle once doomed super-heavy tanks. The concentration of enormous power in one unit of equipment makes it too valuable to risk on the battlefield and too noticeable to protect from enemy fire. To date, only 10 Zubr-class ships remain in the world. 4 are in service with the naval forces of Greece, although their decommissioning is expected in the foreseeable future due to unresolved problems with maintenance and spare parts. 4 are in the Chinese fleet and remain the most actively used of all surviving examples. Beijing regularly involves them in exercises in coastal waters, and only 2 ships remain with Russia, the country that gave birth to them and that once planned to build dozens of such machines for lightning-fast landing operations along the entire length of its sea borders. These 2 Russian Zubrs have long since exceeded their planned resource, and each of their trips to sea is a feat of engineers and technicians maintaining the aging machines in working condition. The Zubr thus remained unsurpassed. In the nearly 4 decades since its appearance, no state on the planet has even attempted to create anything similar in scale. Soviet engineers from the Leningrad Bureau Almaz in the mid-70s aimed at a project that was ahead of its time and built a machine that still stands apart in the history of world shipbuilding. A 500-ton flying ship armed with missiles and guns, capable of flying out of the mist at a speed of over 100 kilometers per hour and throwing an entire tank company onto the shore. No screenwriter could come up with such a thing because even without any movie, it sounds absolutely insane. But it exists, it is real, and it still goes to sea under Russian, Greek, and Chinese flags.